Okay, good evening and welcome back to Intro to Statistics. So today we're going to talk a little bit about probability. Okay, I promise you I'll get back to chapter 5, but I've done it several times and I'm getting a little frustrated with it. So I'm going to skip forward to chapter 5 and we'll go back and infill some other stuff when we get there. Okay, so let's talk a little bit about probability. Okay. We usually break this down into a couple of different ways. The probability could be approximated, but our basic definition, okay, is we're going to count the number of times something was a success divided by the total number of experiments. Okay, so we have number of successes divided by number of experiments. If I'm polling, say, sixth graders, have you tried tobacco? Okay, now maybe 3 out of those 20 sixth graders have tried tobacco. We would have 3 successes out of the 20 experiments. I asked 20 kids whether or not they've tried tobacco, and then 3 of them out of that 20 said yes. Under no circumstances except for this experiment would 3 children trying tobacco be considered a success. Okay, but for the purposes of probability, that's just the language that we use. We tried an experiment. Did you use tobacco? Yes, it's a success. 3 out of 20, that's going to be our probability. So our probability is going to be 0.15. Okay, 3 divided by 20, you guys can check this. And that's just what we're doing here, okay? So we're just saying 3 divided by 20. But I just want you to pay attention to the fact that, oh, sorry, 3 divided by 20. There we go. 3 divided by 20. Okay. But I just want you to realize what the lingo is, not necessarily what any kind of ethical or moral baggage comes with it, with the English language. Okay, so that's just going to be our way of saying this. Okay. Later on, we're going to talk about a lot of times we have binomial distributions. We're going to be talking about true, false. A lot of times we talk about births, so boy, girl. I know that there are boy, not girl, but we're not. We're just going to say boy versus not boy. We're not going to do that. We're just going to say boy, girl. Effectively, heads or tails, true or false. We're just going to keep it to 2 options. I know there's more, but we're just going to keep it with the 2 because we're starting intro to statistics. And we don't really want to complicate things with real life. Okay, so forgive me for that, please. Okay. Empirical probability is what empirical means is we tried an experiment. Okay, that's all it means. We tried the experiment. So if you tell a child, hey, I think the probability of rolling doubles is going to be 1 out of 6. If you have a child who's been properly raised, they shall take those 2 dice and they will roll them dozens upon dozens of times to see whether or not they got 1 out of 6, to see whether or not they roll doubles. Okay, because they shouldn't believe you. They say, "Nuh-uh, let me try it." The law of large numbers, okay, says that as your number of experiments, we're going to call that n, tends towards infinity. Okay, so tends towards infinity, tends towards. Okay, that the theoretical probability will approach the empirical probability. Okay, now with humans, you got to count every attempt. Every experiment counts as an attempt. Like, well, it didn't turn out the way you liked it. Like, well, that's too bad. It still counts as the experiment. You still have to count it. Okay, you could be a failure. That's okay, but we're going to count them all. Okay, every time somebody do an experiment, we're going to count. That's going to count. Okay, so there's no like, well, that's a do-over because no, there's none of that. Right? We're just going to count up all the experiments and the time you had a success or the successes versus the total number that we tried. Okay, humans are not good at estimating probabilities. We're all bad at it, me included. Okay, it's just something that humans are not good at. Okay, so that's what we have for that. One of the other words we're going to start using is sample space. Okay, what all the sample space means, I had to write this down. Is this the collection of all possible outcomes listed? Okay, and that's how we know like what the successes are divided by the total possible outcomes. That's a theoretical probability. Okay, and that's how we're going to do that. Okay, we have three rules of probability. That we have a probability of an event. Okay, this is the probability of event A. Pick any event you like. Probability it's going to rain. Okay, if probability of event A is equal to 0, that's possible. Well, that means it's impossible. Okay, probability of an event A is equal to 1. That's a certainty. And everything else, probability has to be a number between 0, right? There we go. Probability has to be between a number between 0 and 1. It can include 0, it can include 1, that's okay. But it has to be between 0 and 1. So if somebody tells you the probability that something is happening is 1.2, that's not a probability. We're going to throw that right out. Probability that an event happens is negative 1/2. Like, we don't do that. Okay, we don't do like, well, it didn't happen. It happened less than 1 times divided by the 2 experiments. We don't worry about that. So your probabilities have to be positive. They have to be between 0 and 1. That's just the way that we've defined it. And so if they try to trick you into saying the probability of an event is negative, it's like, oh, you're trying to lie to me. I'm not going to fall for it. Okay, so we'll go ahead and we'll do a couple of problems here just to kind of get our hands on what's going on and see what's going on here. Okay, so assume a fair die is rolled. When it says a fair die, it means that all the outcomes are equally likely. Okay, then we also say things like we're not going to worry about the die rolling into a crack on the sidewalk and not coming up with a value. Okay, it's not going to suddenly balance on its corner. Okay, that it has to be one of these things. We're not going to worry about like what happens with everything else that could happen. It can't. Okay, these are the possibilities that could happen, and because it's fair, it's going to be equally likely. So that's not reality. Like I know, but right now we're just trying to get a handle on how to calculate probabilities, and we can make things more complicated later on. But for the beginning parts of this, these are the only options that can happen, and you're not going to get one that's going to suddenly balance on its side or on its corner or on an edge. It's just we're not going to allow that possibility. Okay, since all the outcomes are equally likely, find the probability that the value comes up as less than 5. So the first thing we have to ask ourselves, what numbers are less than 5? Is 5 less than 5? So we have 1, 2, 3, 4. 5 is not less than 5. We're not going to include 5. Okay, 6 is certainly not less than 5. So we have 1, 2, 3, 4 things that could happen. And then we have, what's our sample space? How many things are in a sample space? There's a total of 6 things in a sample space. And then you're going to go ahead and reduce, and you're going to say, oh, okay, that's 2/3. Okay, so the probability that something is less than 5 is 4/6. But if it's within your 12 by 12, I can do multiplication tables. We're going to reduce, and we're going to say that's 2/3. Okay, so I'll let Alex handle that rule for us. But generally, that's what we're going to do. If it says you should reduce, then we should reduce. Okay, and we're just going to go with that. Okay, so check, and then say yay, and then move on with our lives. Okay, so that's all we do is we count up the number of successes divided by the total possibilities. And then we make that a ratio, reduce, and then we're going to go. Okay, so number 2, so assume the coin is tossed twice. The coin may not be fair. The sample space consists of the outcomes: 2 heads, a heads and a heads, a heads and a tails and a heads, and a tails and a tails. is this a given probability model? Well, are all of these things positive? Yes. Are they all between the values of 0 and 1? Yes. Well, then it is a probability value. Okay, we have all the possibilities that are listed here. We have a probability associated with each outcome. I'd really like to say that they should add up to 1 as well. I'm not sure if the book quite goes into that, so I'm just going to double check to see if that's true. But really, I would like all the probabilities to add up to 1. Okay, so we have a net order plus 0.25 plus 0.54. Get that, they add up to 1. I am really happy saying yes. But mostly at this point, all we're looking for is, are they between 0 and 1? They sure are. Are any of them negative? No. And then we'll add in that third one. Do they add up to 1? Okay, so we'll say check, like yay. And by the way, every outcome, every possibility has a number associated to it. Okay, so that's one of the other things. That number could be 0, that's okay, but we should associate a probability, a number to all the different outcomes. Okay, we'll go on with our lives, and we'll go with 3, number 3 here. So in a poll, 494 people out of 1,723 people said they prefer to sleep in on Saturday mornings. That sounds like a good plan. I like that. They're going to say, what is the probability that a person who prefers to sleep in on Saturday mornings? So all we're going to do, okay, we could define A. We say A likes to sleep in Saturday morning. Okay. And all we're going to do is say, what's the probability that we picked an A? Then we're going to have 494 out of, how many people did we ask? We had 494 successes in the 1,723 experiments. We asked those people, do you like to sleep in on Saturday mornings? I can't imagine anybody saying no, but there we go. Okay, a lot of people did. So we're just going to go ahead and calculate that probability. Let's say something clever like 494, okay, divided by 1,723. And because they, what did they say? They want round your answer to 4 decimal places. That's what we're going to do. Okay, so we're just going to go ahead. We're going to move this off to the side. We'll move this off to the side here. We're just going to say 0 point, and I'm just going to write down 2867. Okay, 2867. They just wanted 4 decimal places. That's the usual way that they want to do this. Okay, we'll check. Say hooray, and we'll go on with our lives. Okay. Interpret this probability by estimating the percentage of people that prefer to sleep in on Saturday mornings. All we're going to do is we're going to multiply and divide by 100. Okay, that's what a percentage means. It's percentum, okay, per 100. Okay, so we're going to take our, what do we have here? We had 0.2867, and we're going to multiply by 100 and divide by 100. You see how this kind of looks like that value, that symbol? That's how they got the percentage. They multiply and divide by 100. Okay, so we're going to say this is 28.67%. A lot of times, especially in face-to-face, students ask me, I'm like, do you want it as a percentage or do you want it as a decimal? Depends on who you're talking to. If you're providing this number for an engineer, chances are they're going to do something else with this number. You want to give them this decimal place. If you're writing an article for a newspaper, you want to just deal with it as a newspaper. You want to talk to like regular people, not engineers. You probably want to turn things into percentages because people have an easier time looking at 28.67% rather than 0.2867. Okay, it really depends on your audience, but it's not something that I ever wanted to worry about. Like if I have 50 cents, do I have half a dollar? Do I have 50% of a dollar? Do you really want to argue, or do I have 50 cents? Do you really want to argue the difference with somebody? I don't. So I never really cared about how people express this number, but I'm just going to tell you that normal people like looking at percentages, engineers like looking at decimals. It's just the way it goes. And just to keep that in mind. Who's your audience, and write your number for the audience that you're looking for. So we're just going to change this to 28.67, 0.67%. Okay, and we'll go on with our lives with that. Okay, round your answer to 2 decimal places. We've done that, so we're checking it. We're good. Okay, so that's how you do percentages, and that's empirical probability because we conducted an experiment. 494 people out of the 1,723 people we asked said yes. So I'll go ahead and leave you with that, and I'll come back with another chapter 5. Okay, thank you.